Hello there, and welcome. I'm truly glad you found your way here to this quiet space. Maybe you had a long day, your mind still buzzing with the remnants of everything that needed to be done. Or perhaps you're simply the kind of person who finds a deep, quiet comfort in the gentle unraveling of facts, in the soft glow of understanding rather than the pressure of a screen. Whatever the reason, tonight's journey is made just for you. You have absolutely nothing to do now but rest. Let your mind relax. Your breathing slow to a soft, steady rhythm. Feel the weight of your body settling as if the very pull of the earth has softened its grip. Just for you, just for now. Because tonight, we will sit together by the cosmic hearth. We will gently explore the most relaxing facts about fire. Not the wild, roaring blaze, but the quiet, dancing flame. The patient glow of embers, the silent language of candlelight, the ancient, gentle warmth that has called humans to rest for 1,000,000 years. But beneath its familiar, flickering surface, fire holds deep and quiet secrets. We will wander through the silent chemistry of a single spark. We will ponder why a flame is shaped like a tear, and what the faint blue at its heart is quietly trying to tell us. We will travel from the first fire ever kindled on our planet to the last flame that will ever flicker in the cosmos. Some of what you hear may surprise you, or at least spark a final, gentle curl of curiosity as you drift away. And just before we begin, if these calm, deep explorations help you unwind at the end of your day, consider liking this video or subscribing to the channel. It's a very small thing, but it helps other quiet souls just like you find their way here to rest, one sleepy soul at a time. Now let's begin. The first spark. Birth of a flame. Fire does not simply appear, it is patiently invited into being. It begins not with a roar, but with a quiet chemical conversation, a whispered agreement between three gentle partners of fuel, the oxygen in our air, and just a little bit of warmth. The quiet birth of a flame is a process older than humanity itself, known as the fire triangle. This is not a geometric shape you can hold, but a gentle, invisible balance. The fuel could be the dry patience of wood, the smooth richness of wax, or the invisible generosity of natural gas. The oxygen is the ever-present breath of our atmosphere, a constant and willing participant. The heat is simply the catalyst, the soft knock on the door that begins the conversation. When heat gently touches a fuel, it coaxes its molecules to become restless. This quiet, unseen transformation is called pyrolysis. The solid wood does not simply melt, it quietly unravels, releasing a soft, invisible cloud of volatile gases. These gases are the true fuel of the familiar flame, the soul of the fire released from its physical body. These gaseous molecules, now warmed and free, begin to dance and collide with oxygen in the air. With enough energy, these collisions become gentle embraces, forming new, more stable bonds. This quiet, passionate reunion is what we call oxidation. It is a slow, intimate release of energy that was stored in the original bonds, energy that once came from the sun. The light of a flame is simply matter settling into a state of calm. As the excited gas molecules form new bonds, they release their excess energy in the form of tiny, gentle packets of light, or photons. The familiar yellow glow of a wood fire is a blanket of soot particles heated to incandescence, each one a microscopic star, burning for just a moment before it drifts away as soft, black ash. A flame is not a thing but a process. It is a slow, beautiful river of chemical change, a region where this transformation is happening continuously. It is a fragile, flowing architecture of reacting gases, a temporary structure of light and heat that exists only as long as the gentle conversation between fuel and air continues. The gentle blue at the base of a candle flame is a window into its pure chemistry. Here, the fuel molecules are first meeting the air, beginning their initial, efficient oxidation. This blue light is emitted directly by excited molecules, a cooler, more subtle glow than the bright yellow of incandescent soot, a quiet overture before the main symphony of light. The distinctive, tear-like shape of a flame is a slow dance between gravity and heat. The burning gases are hot and thus lighter, so they rise patiently in a flow called a buoyant plume. This upward journey pulls fresh, oxygen-rich air in from the sides, sculpting the fire into that familiar, slender dancing form, a silent tribute to the invisible forces that hold our world. A spark is not a miniature flame, but a tiny, heated traveler. It is often a small particle of metal or mineral, heated so intensely by friction or electricity that it glows. As it flies, it delivers its concentrated warmth to a fuel source, a silent messenger carrying the invitation for the larger, slower conversation of fire to begin. The concept of a flashpoint is one of quiet patience. It is not the temperature at which a material bursts into flame, but the specific warmth at which it has released enough vapor to whisper to the air to begin that gentle, chemical conversation. It is a threshold of potential, a silent tipping point into visibility. Spontaneous combustion is a myth for most materials, a story of suddenness that belies reality. True, spontaneous ignition is a process of profound patience, where a material oxidizes so slowly internally that its own trapped heat builds up over hours or days, eventually reaching its own ignition temperature. It is not an explosion, but a slow, quiet awakening. Even without a visible flame, oxidation continues its gentle work. The slow rusting of an old nail in the rain, the patient browning of a sliced apple in the air. These are the same quiet molecular conversations. They are fires burning in the slowest of motions, reminders that the line between decay and flame is merely one of speed and intensity. The very atoms that dance within a flame, the carbon, the hydrogen, the oxygen, are ancient travelers. They were forged in the hearts of long-dead stars, scattered across the galaxy, and eventually found their way into a piece of wood or a pool of wax. When we light a fire, we are simply asking these ancient stardust atoms to release a tiny fraction of their stored primordial energy to share a little of their old cosmic light, the anatomy of a candle. A single candle flame is not a simple thing, but a self-contained universe of gentle physics. It is a miniature world where gravity, chemistry, and light engage in a silent, stable dance, all contained within the space of a single, flickering tear. When you first light a candle, the flame does not simply burn the solid wax. It patiently melts a small, tranquil pool at the wick's base, a tiny liquid reservoir. The wick itself acts as a humble capillary channel, silently drawing this liquid fuel upward through the simple, persistent force of cohesion, defying gravity drop by drop to deliver sustenance to the flame. The wick is not merely a fuse, but the flame's diligent servant. As the liquid wax is drawn to the tip, the intense heat vaporizes it, transforming the solid fuel into the invisible gas that the flame truly consumes. The wick itself begins to char and curl, a self-regulating mechanism that ensures its tip remains in the hottest part of the flame, being slowly consumed but always present, a quiet sacrifice to sustain the light. Look closely at a candle flame, and you will see it is composed of several gentle layers. At the very base, nestled just above the wick, lies a small, dark, and almost invisible region. This is the zone of pyrolysis, where the liquid wax is first transforming into vapor, a place of preparation and quiet change, not yet of light. Rising from that dark base is the faint, blue-violet inner cone. This is the heart of the flame's chemistry, where the vaporized fuel first meets oxygen and begins to break down in a process of partial combustion. This blue light is a luminescent glow, from excited molecules, a cool, efficient, and quiet light that is often overshadowed by the brighter glow that surrounds it. The main body of the flame is the soft, radiant yellow that we most associate with candlelight. This glorious light comes not from the gases themselves, but from millions of tiny, incandescent soot particles. These microscopic specks of carbon are heated to a glow within the flame, each one a tiny, short-lived star, collectively weaving the tapestry of warm, comforting light that we find so soothing. The very tip of the flame is often a faint, wispy, and nearly transparent region. Here, the combustion is finally complete. Any remaining soot particles are fully oxidized, and the last of the fuel is converted into invisible carbon dioxide and water vapor. It is the quiet exit point where the transformation concludes and the fire's products gently merge back into the air. The flicker of a candle is a language of air currents. It is the flame's soft visual whisper, responding to the gentlest breath in a room, the slow opening of a distant door, the rising heat from your own hand. This constant, gentle motion is a reminder that the flame is not an object, but a sensitive process, deeply and beautifully connected to its environment. A candle flame is a masterpiece of self-regulation. If you were to draw out too much wax vapor, the flame would grow larger and brighter for a moment. But this very act would pull in more cool, oxygen-rich air, which would then cool the reaction and gently temper the flame's size, bringing it back to its stable, teardrop equilibrium. It is a system in perfect patient balance. The soft, gentle hiss of a candle is the quiet sound of water. The hydrogen atoms from the wax combine with oxygen to form water vapor. The subtle sound you hear is the miniature steam engine at work. The expansion of these newly formed gases, a tiny, audible signature of the chemical transformation creating the peaceful scene. When a candle smokes after being extinguished, it is telling a story of interrupted travel. The hot, vaporized wax continues to rise from the wick, but without the flame's heat to fully combust it, it simply condenses back into a visible, white stream of tiny, liquid wax particles. It is the ghost of the flame, a final, fading breath of what was once light and warmth. The calm, steady light of a candle in a still room is a testament to a perfect, gentle cycle. The flame creates its own draft, drawing in fresh air and expelling the warm exhaust, which in turn shapes the flame and feeds it anew. It is a closed loop of cause and effect, a small, stable system of creation and release, burning patiently in the quiet dark. The silent language of light. The light from a fire is not a single, simple glow, but a quiet conversation of colors, each hue whispering a different secret about the flame's inner world. It is a gentle spectrum of information, a silent language written in the physics of excited atoms. The deep, vibrant blue at the heart of a gas stove flame is a sign of perfect, efficient combustion. This color emerges when hydrocarbon molecules are broken apart completely, and the excited radicals emit light in a specific, energetic part of the spectrum. It is the flame's quiet, confident voice, speaking of a clean and complete transformation. The soft, orange glow of a campfire is the light of 1,000,000 tiny suns. Each microscopic soot particle, heated by the surrounding gases, radiates a continuous spectrum of light, a process called incandescence. The color is a direct measure of their temperature, a warmer, yellower glow for hotter particles, a deeper, redder ember for those that are slowly cooling. It is the same ancient light that comes from the stars. When you sprinkle salt on a flame and it flares a brilliant yellow, you are witnessing the unique signature of the sodium atom. The heat excites these atoms, and as they relax, they emit light almost exclusively at this specific, warm yellow wavelength. It is a fingerprint of an element, a brief, vibrant shout in the flame's otherwise soft, continuous murmur. A flame's color can act as a gentle thermometer. A cooler red flame may be around 800 degrees Celsius, while a hot, white flame can exceed 1400. The progression from red to orange, yellow, and finally white is a slow visual symphony of increasing energy, a quiet display of how much warmth is being patiently released. The faint, almost magical green hue you might see in a copper-enhanced fire is another atomic signature. Copper atoms, when excited by heat, release their energy in the blue-green part of the visible spectrum. This is not the light of something burning, but the light of an element being gently awakened and singing its own distinct color back to the world. The reason we can see through a flame is that it is mostly transparent. The bright glow comes from tiny solid particles suspended within the hot gases. A perfectly clean soot-free flame, like that of pure alcohol, burns with a pale, nearly invisible blue light, a quiet ghost of heat that dances above the wick without casting a strong shadow. A candle flame emits a faint, continuous whisper of infrared radiation, a warmth we feel on our skin long before we can be burned. This is the same energy as visible light, but with a longer, slower wavelength, a gentle, invisible embrace that travels from the fire to soothe our hands and faces, a silent communication of heat. The flickering of a fire is a complex, chaotic rhythm, a visual lullaby without a repeating pattern. This is because the flame is a turbulent fluid, its shape constantly molded by the rising hot gases and the entrainment of cooler air. Its endless, unpredictable dance is a soft, visual representation of chaos itself, which our minds find so effortlessly relaxing to watch. The concept of a cool flame exists at the very edges of combustion. These are faint, blue flames that can occur at temperatures as low as 400 degrees Celsius, often seen during the slow, smoldering oxidation of fuels. They are the quietest possible version of fire, a slow, patient whisper of a reaction, barely strong enough to produce visible light at all. The light from a fire is always moving outward, gently traveling in all directions at once. Each photon is a tiny messenger carrying a small packet of energy away from the reaction. When this light touches a surface, it is absorbed, its journey ended, its energy transformed back into a gentle warmth. The fire is thus, slowly and patiently, broadcasting itself into the room. In the complete silence of space, a flame would burn with a very different, more subdued voice. Without gravity to create convection, it would not form a teardrop shape, but would become a small, blue, nearly spherical halo of flame, fed only by the slow diffusion of oxygen. It would be a quiet, contained globe of light, a muted and patient version of its earthly self. The gentle, pulsing rhythm of a firefly's light, while not fire, is a related miracle of cold light, or bioluminescence. It is a highly efficient chemical reaction where almost all the energy is released as light, with virtually no wasted heat. It is nature's own version of a perfect cool flame, a silent, rhythmic signal blinking softly in the summer night. When you gaze into a fire, the silent language of its light speaks directly to an ancient part of your mind. The soft, warm colors, the gentle, unpredictable motion, the steady emission of infrared warmth, all these elements signal safety, community, and the chance to rest. The fire's light does not demand your attention. It simply offers a space for your thoughts to gently unravel and drift away. The unanswered whisper. For all our understanding of fire's basic principles, a quiet shroud of mystery still envelops the dancing flame. There are whispers in its behavior that even the most advanced science has yet to fully decode, reminding us that humble wonder is the truest response to nature's simple marvels. The precise, moment-to-moment flicker of a flame is a signature of beautiful chaos. While we understand the broad forces of buoyancy and air currents that shape it, predicting the exact dance of a specific flame for more than a second into the future remains an elusive goal. Its path is a product of innumerable microscopic variables, a soft visual poem of turbulence that we can admire but never truly author. Scientists are still unraveling the subtle chemistry of soot formation. The journey from a simple gas molecule to a complex carbon-based soot particle involves a series of poorly understood steps, a silent assembly line in the heart of the flame. We know it happens, but the exact pathways and intermediaries remain a subject of quiet, ongoing investigation. The phenomenon of cold flames continues to perplex and fascinate. These are faint, blue chemical reactions that can occur at temperatures far below what we typically associate with fire. How these low-temperature oxidation processes sustain themselves and why they appear so different from hot flames is an active frontier in combustion science, a gentle enigma of slow burn. We do not fully understand why some materials exhibit a phenomenon called discrete burning. This is when a fire seems to spread in a pulsating, wave-like manner across a fuel source, like a line of glowing embers igniting one after another in a rhythmic sequence. The underlying mechanism for this stop-start propagation remains a topic of quiet debate. The transition from a slow, smoldering fire to a rapid, flaming blaze is a critical threshold that is still not perfectly predictable. The exact point at which enough heat and volatile gases are produced to leap from a quiet, glowing state to a dancing, open flame involves a complex interplay of factors that can be surprisingly delicate and difficult to model. The way a flame interacts with its own sound is a field of soft inquiry. A flame can be subtly influenced by acoustic waves, and it in turn generates its own faint, inaudible pressure waves as it consumes fuel. This two-way, silent conversation between fire and sound is a subtle layer of its existence that we are only beginning to listen to. In microgravity, aboard the International Space Station, flames become small, blue and spherical. But within these quiet orbs, strange things happen. The rules of combustion change without gravity-driven convection, and scientists have observed mysterious, slow-burning flames and unusual extinction behaviors that challenge our earthbound understanding of how fire lives and dies. The concept of turbulent flame speed is a central mystery in large fires. It is the rate at which a flame front propagates through a chaotic, turbulent field. While we have models, the precise calculation of this speed in a real-world, unpredictable environment like a forest fire or an explosion remains one of the great, unsolved challenges of fluid dynamics. There is a curious and unexplained stability to the base of a candle flame. It anchors itself to the wick with remarkable fidelity, resisting the turbulent rise of the hot gases above it. The exact physical and chemical mechanisms that provide this stable anchor point, this quiet foothold for the flame, are more complex than they appear and are still being gently probed. The process of auto-ignition, when a fuel spontaneously bursts into flame without an external spark, is governed by complex chemical kinetics that are not fully mapped for all substances. Predicting the exact moment and conditions for this quiet, spontaneous birth, especially in new synthetic fuels, is a deep and practical puzzle. We do not know with absolute certainty how the first fire on Earth behaved. The composition of the ancient atmosphere, the type of fuel from primordial plants, and the exact conditions of that first monumental lightning strike are all variables lost to deep time. The first flame was a unique event whose gentle character we can only quietly imagine. The ultimate mystery of fire may be its strange duality. It is a destructive force that clears the way for new life. It is a chaotic process that can bring a deep, primal calm to the human mind. We do not fully understand why this agent of transformation is also such a powerful signal for safety and rest, a paradox that has been woven into our psychology since the dawn of consciousness. The sun's distant cousin, the gentle flame dancing on a candle wick, is a distant, quiet relative of the star that lights our day. Both are processes of transformation, releasing light that began its journey in the heart of cosmic creation, connecting the warmth in your room to the vast, patient furnace of the universe. The sun does not burn in the way a log of wood does. Its light comes from a far more powerful patient process known as nuclear fusion. Deep in its core, under immense pressure and heat, hydrogen nuclei gently fuse together to form helium. In this act of cosmic union, a tiny fraction of mass is transformed directly into a vast, flowing river of energy. According to Einstein's timeless equation, every fire on Earth is, in a quiet way, a release of stored sunlight. The carbon in wood, wax, and fossil fuels was once atmospheric carbon dioxide, pulled from the air by plants and algae. These organisms captured the sun's photons, using their energy to build the complex molecules that now, millions of years later, release that same ancient energy as a gentle, flickering warmth in our hands. The very carbon atoms that form the structure of your candle were forged in the heart of a long-dead star. In its final majestic stages of life, a star much larger than our sun fused helium into carbon and oxygen. When that star gently expired, it scattered these newly formed elements across the galaxy, a cosmic seeding that eventually found its way into our planet and into the simple, elegant form of a candle. The flame of a candle and the light of the sun are both plasmas, the fourth state of matter. In a flame, the heat is just enough to strip electrons from some of the gas molecules, creating a faint, ionized cloud. In the sun, the entire core is a raging, dense plasma. They are different in intensity but kin in their fundamental energetic nature. The color of a flame is a gentle thermometer, and the color of a star is the same. Our sun appears yellow because its surface temperature is around 5,500 degrees Celsius. A much hotter star would glow with a blue-white light, while a cooler, aging star would burn with a deep, red ember in the vastness of space. A candle flame is a small, localized event, while the sun is a continuous, spherical reaction. The flame is shaped by gravity pulling cool air in and letting hot air rise, creating its teardrop form. The sun is a perfect sphere because its own immense gravity pulls equally in all directions, containing the fusion reaction in a stable, glowing orb for billions of years. The lifespan of a flame is measured in hours, while the life of a star is measured in billions of years. Yet, both follow a similar arc of birth, a stable middle age where they burn their fuel steadily, and a final, quiet fading. A star's death, whether as a gentle white dwarf or a supernova, is simply the final cosmic version of a flame burning down to its embers. When a star like our sun dies, it does not explode but gently exhales its outer layers into space, creating a beautiful glowing cloud called a planetary nebula. The hot, exposed core of the star, a white dwarf, remains at the center, glowing not from fusion, but from residual heat, like a cosmic ember, slowly cooling over trillions of years. The soot from a candle flame, the carbon that gives it its yellow glow, is the same element that, under immense pressure in the Earth's crust, becomes a diamond. It is also the same element that in the heart of a dying star can be forged into heavier elements like iron and gold. Carbon is a universal traveler, a shapeshifter of cosmic importance. The solar wind, a constant stream of particles flowing from the sun, is the star's gentle breath, slowly shedding its mass into the solar system. In a similar miniature way, a flame releases its own wind, the rising plume of hot gases and the faint, invisible flow of its combustion products, a tiny atmospheric system contained within a room. We do not know if the first fires in the universe flickered on planets, or if they were born in the exotic atmospheres of gas giants or in the dusty disks around newborn stars. The precise conditions for the very first combustion reaction in the cosmos are lost to time, a quiet, unknown spark in the deep, dark, early universe. The energy from the sun takes a slow, meandering journey to reach us. A photon created in its core may take 100,000 years to bounce its way to the surface, and then just 8 more minutes to cross the void to Earth. The light and heat from your fireplace, in contrast, travels instantly from the flame to your skin, an immediate and intimate gift. When you light a candle, you are creating a small, personal star. It provides light against the darkness, warmth against the cold, and a focal point for community and contemplation. This primal connection is written in our DNA. We are drawn to the flame because, on a deep, unconscious level, we recognize it as a tiny, tame piece of the same cosmic force that gives us life. The gentle goodbye. Embers and ash. The end of a flame is not an abrupt stop, but a slow, gentle fading. It is a process of patient return, where the vibrant dance of light softens into a deep, glowing warmth, and finally settles into the quiet memory of ash. As a flame begins to die, its bright yellow light is the first thing to go. This happens when the supply of vaporized fuel starts to dwindle and the flow of fresh oxygen is interrupted. The lively dance of soot particles that created the bright glow simply ceases, leaving behind the more subtle red light of the remaining hot carbon. The ember that remains is the pure, solid heart of the fuel, still chemically conversing with the air. This is the process of smoldering combustion, a slow surface-level oxidation that does not produce a flame. It is a quieter, more patient form of burning, releasing its heat in a steady, radiant whisper. The deep, pulsating red of a hot ember is a perfect example of blackbody radiation. As the carbon cools, the wavelength of light it emits lengthens, shifting from a bright orange red to a deeper, darker crimson before finally fading from sight entirely, long before it has cooled completely. The intricate, lace-like structure of a piece of charcoal is a testament to what has been lost. The volatile compounds, the resins, water, and other gases have all been driven out by the heat, leaving behind a fragile skeleton of almost pure carbon. It is the ghost of the wood, its architectural blueprint rendered in black. Ash is the final mineral memory of the fire. It is the non-combustible elements that were always present within the fuel, the calcium, potassium, and phosphorus that the tree drew from the soil and the sun. This fine grey powder is not destruction, but a gentle giving back, a nutrient-rich gift to the earth. The way a log collapses into embers is a slow physical poetry. The cellulose and lignin that gave the wood its strength are consumed, and the structural integrity gently fails. It is a quiet, gravitational surrender, a return to a more fundamental state, piece by piece. The scent of wood smoke that lingers after a fire is the memory of its complex chemistry. These are the heavier aromatic molecules that vaporized but did not fully combust, carrying with them the unique signature of the wood, the terpenes from pine, the vanillin from oak, a fragrant ghost that drifts long after the light is gone. A fire can die from being smothered when it is separated from the oxygen it needs to breathe. This is a quiet, gentle death. The chemical reaction simply slows to a halt, and the heat is absorbed by the surrounding material, leaving the fuel largely intact, but forever changed by the heat it experienced. In the cold silence after a fire, the air itself tells a story of transformation. It is filled with the invisible products of the flame, carbon dioxide, water vapor, and traces of other gases. The fire has subtly altered the very atmosphere of the room, a permanent, though unseen, record of its brief, warm life. The final state of ash is one of profound peace. It is chemically stable, inert, and at rest. It represents the end of the transformation, the conclusion of the energy's journey from the sun to the tree to the flame, and finally to a quiet dust that will nurture new life. It is not an end, but a quiet beginning in a different form. The unseen flame. Fire is not always a visible dance of light. Sometimes it is a silent, unseen transformation happening right before us. These hidden flames reveal a world of chemistry where combustion wears a different, more subtle disguise. In a process called catalytic oxidation, materials can be consumed by an invisible fire. A catalyst, like the platinum in a car's catalytic converter, allows fuel and oxygen to combine at temperatures far lower than a normal flame, producing only heat and unseen gases. It is a silent, efficient burn that leaves no trace of light behind. The human body itself is a site of a slow, metabolic flame. The food we eat combines with the oxygen we breathe in a controlled, cellular process called respiration. This is oxidation, this same fundamental reaction as fire, but conducted at body temperature, releasing the energy that keeps us warm and alive and invisible. Internal hearth always burning. Spontaneous combustion in compost piles is a testament to the power of the unseen flame. As microorganisms break down organic matter, they generate heat. If this heat is trapped, it can slowly raise the temperature until the material begins to smolder on its own. A fire born not from a spark, but from the accumulated warmth of countless tiny, living processes. A cold flame is not a metaphor, but a real chemical phenomenon. During the low-temperature oxidation of certain fuels, a faint blue glow can appear that is barely warm to the touch. This chemiluminescence is a different pathway of reaction, a gentle, cool fire that flickers at the very edge of what we define as combustion. Some fires burn in spectrums our eyes cannot perceive. A hydrogen flame, burning purely in air, produces an intense ultraviolet light that is completely invisible to the human eye. You could hold your hand in this silent, transparent flame and only feel the heat a moment before being burned, a dangerous reminder of the unseen. The concept of a flashpoint describes the moment a fuel becomes ready for an invisible conversation. It is the lowest temperature at which it gives off enough vapor to form an ignitable mixture with air. Just above this point, a flame will not sustain itself, but the fuel is quietly whispering, preparing for a fire that has not yet been born. The embers of a dying fire continue their work in the infrared spectrum. Long after their visible red glow has faded, they continue to radiate heat energy in longer wavelengths. This is a fire of pure warmth, a radiant, unseen farewell that can be felt on the skin but not captured by the eye. In the chemical industry, flaring is a common practice where unwanted gases are safely burned off. From a distance, these massive flares may appear as a faint, shimmering haze rather than a distinct flame. They are vast, industrial candles conducting their work of transformation through a barely visible dancing heat. The phenomenon of phosphorescence is a relative of cold light. When certain materials absorb light energy, they can store it and release it slowly over time. The gentle glow of a glow-in-the-dark toy is not fire, but it shares the principle of stored energy being patiently released as visible light, a slow, cool echo of a brighter source. The silent, destructive fire of rust is oxidation in its most patient form. When iron meets oxygen and water, it slowly transforms into iron oxide, releasing energy so gradually that no light is produced. It is a flame stretched over decades, a quiet, persistent consumption that turns strong metal into fragile, red dust. In the depths of space, molecular clouds are sites of cosmic chemistry, where reactions occur on the surfaces of dust grains. These processes, which create complex organic molecules, are a type of cold, surface-level combustion happening in the vacuum at temperatures near absolute zero, the slowest and most patient fires in the universe. The fire tetrahedron adds a fourth, invisible element to the classic fire triangle, the chemical chain reaction. This unseen sequence of radical interactions is what sustains a flame once it has started. It is the silent, self-perpetuating engine of the fire, an invisible structure of propagating chemistry that is as vital as fuel, heat, or oxygen. We often forget that the flame we see is only a small part of the reaction zone. The preheating zone, where fuel and air are mixing and warming, and the post-combustion zone, where products are still cooling, are both invisible. The visible flame is merely the bright, busy intersection in a much longer, unseen journey of transformation. These unseen flames remind us that the essence of fire is not the light, but the transformation. It is the quiet, relentless process of atoms seeking a more stable arrangement, of energy being released from its chemical bonds. Whether it manifests as a roaring blaze, a body's warmth, or the slow decay of metal, it is all part of the same gentle, universal tendency toward change. The hearth within, fire in the human body. Within each of us, a gentle, metabolic flame burns continuously, a quiet hearth that requires no wood, only breath and sustenance. This internal fire is the slow, patient combustion that transforms the energy of the sun, stored in our food, into the warmth and vitality of life itself. The very process that powers your cells, cellular respiration, is a form of slow, controlled fire. Within tiny structures called mitochondria, the sugars from your meal combine with the oxygen from your breath in a graceful oxidation reaction. This is not a blaze, but a smoldering, a steady, biochemical burn that releases the energy your body uses to think, to move, to simply be. Your core body temperature, holding steady around 37 degrees, is the gentle heat signature of this inner flame. It is the product of countless trillions of these cellular reactions, a testament to the constant, quiet work of conversion happening within you, maintaining a personal climate of life against the coolness of the world. The simple act of feeling hungry is a signal that your inner fire needs more fuel. The gurgle of your stomach is not unlike the sound of air moving over a needy ember. Eating is the act of stoking this biological furnace, of adding new logs to a fire that must never, ever go out. When you shiver in the cold, you are actively fanning your internal flames. Your brain signals muscles to contract rapidly, not to create movement, but to generate waste heat through friction. This is your body's way of throwing its last metaphorical bits of kindling onto the metabolic fire to keep its essential warmth alive. A fever is not an illness, but the body deliberately turning up the thermostat of its inner hearth. By raising its core temperature, the immune system creates an environment less hospitable to invaders. It is a controlled, strategic intensification of your personal fire, a temporary forge to purify the system. The concept of a spark of life is more than a metaphor. It references the precise electrical and chemical ignitions that govern our existence, from the neuronal firing in the brain that creates a thought to the calcium sparks that trigger every single heartbeat, a rhythmic internal lightning that keeps the great, soft machine of the body running. We speak of a person's energy or passion as a fire, and this too has a biological root. The drive to create, to connect, to strive is fueled by the same neurochemicals and hormones that regulate arousal and motivation. This is the fire of the spirit, inextricably linked to the chemistry of the body, a will to live that burns brightly in some and softly in others. The gentle glow of human skin in sunlight is our own form of bioluminescence. While far too faint for our eyes to see, all living creatures emit a tiny amount of light as a byproduct of their metabolic reactions. This is the visible proof of our internal chemical fires, a soft, cellular radiance. As we age, our metabolic fire naturally begins to burn a little lower, a little slower. The mitochondria become less efficient. The production of energy gently declines. This is not a failure, but a natural, gradual banking of the fires, a slow and gentle transition from a roaring blaze to the deep, enduring warmth of glowing embers. The very air we breathe is the quiet bellows for this inner flame. With each inhalation, we draw in the oxygen that is the essential partner to our metabolic dance. With each exhalation, we release the spent gases, the carbon dioxide and water vapor that are the ashes of this lifelong, vital combustion. The warmth you feel in your own hands as you rub them together on a cold day is a direct transfer of your internal fire. The friction creates heat, yes, but the energy for that motion came from the same cellular processes, the same ancient, sun-derived energy that has been cycling through life since its very beginning. When we sleep, our internal fire is gently dampened. Our core temperature drops slightly, our metabolic rate slows, and our breath becomes more regular. This is the body's way of conserving fuel, of banking the coals for the night, allowing for repair and restoration so the flame can burn brightly again with the dawn. This hearth within connects you to every other living thing. From the tallest tree to the smallest microbe, we all share this same fundamental process of slow metabolic combustion. We are all temporary vessels for starlight and sunlight, gently burning as we pass that energy along, one generation to the next, in the great, slow cycle of life. From wildfire to hearth, a story of taming. The relationship between humanity and fire began not with control, but with awe and fear. For countless millennia, our ancestors witnessed fire as a cosmic, untamable force, a wildfire born from a lightning strike, a roaring, indiscriminate consumer that could transform a familiar landscape into a smoldering wasteland. In a matter of hours, the first human to approach a dying wildfire likely did so with a profound and trembling curiosity. The warmth it offered was a stark contrast to the chilling night, and the circle of light pushed back the predatory darkness. This was the first glimpse of fire's dual nature, a destructive power that also held the promise of survival, a terrifying force that could become a protective companion. The mastery of fire is arguably the most significant threshold in human history. The ability to create a spark through friction, to nurture it into a flame, and to sustain it moved fire from a fleeting gift of the gods to a portable, personal tool. This was the moment we began to tend our own miniature suns, carrying them with us as we migrated across the planet. With control came the hearth, the literal and symbolic center of early human society. The hearth was more than a source of heat and light. It was a kitchen, a workshop, a gathering place, and a fortress against the night. The social bonds formed around its flickering light are the foundations of community, storytelling, and culture itself. The campfire represents the perfect balance between the wild and the domesticated. It is a fire that we consciously build and contain, yet it retains a flicker of its primal, unpredictable spirit. Its crackle is the sound of a tamed wilderness, a gentle reminder of the raw power we have learned to invite as a guest. Fire allowed for the expansion of the human diet and the development of the human brain. Cooked food is more easily digested, providing a greater yield of energy from the same amount of material. This nutritional surplus is thought to have fueled the growth of our large, complex brains, literally shaping us into the creatures we are today. The first technologies were born from fire's kiss. The discovery that fire could harden wood and later, through kilns, transform soft clay into hard, durable pottery revolutionized daily life. This was the beginning of materials science, a slow understanding that fire was not just a tool, but a transformer of matter itself. The control of fire fundamentally altered the human relationship with time. A carefully maintained fire could burn through the night, effectively extending the day. This provided more time for social interaction, tool-making, and the development of complex language, all under the gentle, encouraging glow of the flames. The concept of a keeper of the flame emerged as a vital social role. In many early communities, certain individuals were tasked with the solemn duty of ensuring the community's fire never went out. Relighting a fire from scratch was difficult. It was far easier to keep a single flame alive, passing its care from one generation to the next. Fire also became our first great tool for landscape management. Indigenous peoples across the world learned to use low-intensity, controlled burns to clear undergrowth, encourage the growth of desirable plants, and create habitats for game animals. This was not the wildfire of destruction, but a thoughtful, applied fire of renewal and stewardship. The journey from wildfire to hearth is a microcosm of human civilization. It mirrors our own journey from being subjects of nature to becoming participants within it. We learned we could not command the storm or the earthquake, but we could coax a piece of the sun to live with us, to work for us, to protect us. The modern fireplace in a home is a direct descendant of that primordial hearth. It is a ritual space, a symbolic center. Even when its heat is no longer necessary for survival, its light continues to draw people together, fulfilling the same ancient, deep-seated need for community and contemplation that it did 100,000 years ago. Today, we contain fire in the miniature sun of a light bulb and the controlled explosion of a car engine. We have harnessed its principles so completely that we often forget its wild origins. But when we sit before a campfire under a blanket of stars, that ancient connection is instantly restored. We are once again the storytellers and the flamekeepers, sharing a moment of warmth in the vast, cool universe. The rhythm of the forge. Fire is the great patient craftsman of the material world, a silent partner in the slow transformation of Earth's raw materials into the substances of civilization. Its rhythm is not one of haste, but of gradual, persistent change, applied over centuries to unlock the potential hidden within stone and sand. The first metal to be wrested from its rocky prison was likely copper, discovered when a campfire was built upon a copper-rich ore. The slow, sustained heat of the flames performed a quiet alchemy, reducing the ore to a malleable bead of pure metal, a glinting surprise left in the ashes, hinting at a new age of possibility. The forge became the heart of this new age, a controlled inferno where the blacksmith learned the language of heat. The rhythm was simple and profound: heat, hammer, and quench. Fire softened the stubborn metal. The hammer gave it form, and the water gave it strength. A cycle repeated countless times to create a single tool. The creation of bronze marked humanity's first step into alloying, a dance of fusion guided by fire. By heating tin and copper together in a crucible, a new, harder metal was born. This was not a simple melting, but a chemical marriage performed in a vessel of flame, creating a material that was greater than the sum of its parts. The discovery of iron required a more intense and patient fire. Iron ore demands a higher temperature and a chemical environment rich in carbon monoxide to release its metal. The bloomery furnace, with its charcoal fuel and forced draft, was a quiet revolution, a specialized hearth that finally unlocked the strength of the most common metal on Earth. The transformation of sand into glass is one of fire's most magical acts. In the intense heat of a specialized furnace, crystalline sand grains lose their rigid structure and merge into a viscous, liquid continuum. As it cools, this supercooled liquid retains the random molecular arrangement of a liquid, yet possesses the solidity of a stone, a permanent capture of a molten moment. The art of the glass blower is a dance with fire's plasticity. By gathering a molten mass on the end of a blowpipe, the artisan can breathe a bubble of air into its heart, and with simple tools and gentle rotation, shape it into forms of exquisite thinness and complexity. It is a collaboration between human breath and fire's liquidity. The firing of clay is a ritual of permanent change. When soft, waterlogged clay is subjected to the furnace's heat, the water is driven out, and complex silicate structures undergo a chemical metamorphosis. The clay is reborn as ceramic, a new substance that is hard, durable, and able to hold water once more, but in a fundamentally different state of being. The production of lime for mortar and plaster is another of fire's quiet transformations. Limestone, a seemingly solid rock when heated in a kiln, releases carbon dioxide gas and turns into quicklime. This caustic powder, when mixed with water, becomes a paste that slowly hardens by absorbing carbon dioxide from the air, effectively reversing the process that created it, a cycle of stone guided by flame. The refining of precious metals like gold and silver is a purification by fire. Impurities, being less noble, oxidize and are drawn off or absorbed into a crucible, leaving behind the pure, dense, and lustrous metal. This process of cupellation is a slow, meticulous cleansing, using fire's appetite to consume everything but the desired element. The smelting of steel is the pinnacle of fire's metallurgical art. By carefully controlling the amount of carbon absorbed into iron, a material of unparalleled strength and versatility is created. The process, whether in a Bessemer converter or an electric arc furnace, is a dramatic ballet of sparks and light, a modern forge continuing the ancient rhythm on an industrial scale. The creation of cement, the literal binder of modern civilization, is a product of intense, sustained fire. A mixture of limestone and clay is heated in a rotating kiln until it fuses into clinker, which is then ground into a powder. When mixed with water, it undergoes a hydraulic reaction, slowly crystallizing into a rock-like solid, a man-made stone born of flame. Even the charcoal that fueled these early forges was a product of patient, smothered fire. Wood was carefully stacked and covered with earth, then set to smolder for days. In the absence of sufficient oxygen, the volatile components were driven off as gases, leaving behind a fuel that burned hotter and cleaner than wood itself, a concentrated form of fire's potential. The rhythm of the forge is a rhythm of potential realized. It is the slow, persistent application of heat that coaxes, transforms, and purifies. From the first copper bead to the steel girders of a skyscraper, the story of our built world is written in the soot of 1,000 million fires, each one a testament to our partnership with this most fundamental of elemental forces. The ethereal fuel, at its most fundamental level, fuel is not a substance but a vessel of captured time. It is a battery for sunlight, a repository where the energy of a star has been patiently stored in the chemical bonds of matter, waiting for the gentle kiss of heat to release it back into the world as warmth and light. A log of wood is a block of solidified sunshine. Over decades, a tree acted as a gentle solar collector, using photosynthesis to weave the ephemeral energy of photons into the sturdy chemical architecture of cellulose and lignin. When we burn wood, we are simply unraveling that patient work, asking the tree to release its stored summers in the span of an evening. The wax of a candle is a more refined form of captured light, often derived from the petroleum that was once ancient plankton, or from the honeycombs of bees that gathered the sun's energy from flowers. Wax is a dense, efficient fuel. Its long hydrocarbon chains contain a quiet potential, a slow-burning patience perfect for a steady, gentle flame. The fossil fuels we call coal, oil, and gas are the grand archives of the planet. They are the compressed remains of vast ancient forests and marine organisms, their solar energy preserved under immense pressure and heat for hundreds of millions of years. Burning them is like reading a geological scroll written in sunlight, a rapid release of deep planetary memory. But fuel can be more ethereal than mere matter. The human will to survive, the drive to push through cold and darkness, is an intangible fuel that has guided our relationship with fire. It was this inner spark of determination that first compelled us to approach the wildfire and learn its secrets, to nurture a flame through a long, freezing night. In a metaphorical sense, inspiration is a fuel that ignites the mind. A new idea can arrive like a sudden spark, illuminating connections that were once hidden in darkness. This cognitive fire can then be fed by curiosity and knowledge, growing into a sustained blaze of creativity and innovation that can reshape a life or even a culture. Even emotions can serve as a kind of fuel. A deep, burning passion can provide the energy for great achievements, while a slow-burning contentment can offer a steady warmth through life's ordinary moments. Conversely, the smouldering embers of grief or anger can consume a person from within, demonstrating that not all internal fires are life-giving. The very air we breathe is the silent, gaseous fuel that makes combustion possible. Oxygen is the great enabler, the universal reactant that partners with the stored energy in physical fuels. Without this invisible, ethereal participant, the most perfect log or the purest wax would remain inert, a locked treasure with no key. In the human body, the food we consume is our biological fuel, but beyond its calories, it is also information. The nutrients and compounds within our food provide the instructions and materials for repair, for growth, for thought. This is a fuel that does not just burn, but builds and rebuilds the very vessel that contains it. In the cosmos, hydrogen is the ultimate elemental fuel. It is the primordial substance that feeds the nuclear fusion in stars, the engine of the universe. This simple atom, forged in the Big Bang, carries within its nucleus the potential for the light of a billion suns, a clean, profound fire that requires no oxygen, only gravity and time. The concept of a catalyst reveals that some fuels are not consumed, but enable consumption. A catalyst is a spiritual guide for molecules, lowering the energy required for a reaction to begin. It is a fuel for transformation itself, a silent participant that facilitates change without being changed, a gentle hand that opens a door. We sometimes speak of a person's inner fire growing dim. This is more than a metaphor. It describes a state where the metabolic, emotional, and motivational fuels have dwindled. Recovery is then a process of restoking, of seeking out new sources of light and warmth, of finding new logs to place upon the personal hearth. The most ethereal fuel of all may be consciousness itself, the quiet awareness that observes the flame. This subjective experience, this capacity for wonder, is what transforms a chemical reaction into a thing of beauty, a source of comfort, a focus for meditation. It is the invisible witness that gives fire its meaning, the final, essential element in the long journey from sunlight to soul. The oldest flame, deep within the earth. There are fires that have forgotten when they were first lit. These are not the quick, bright flames of a match, but slow, geological fires that have smoldered for centuries, their age measured not in hours, but in the slow turning of generations. A coal seam fire is one of the planet's most patient and persistent phenomena. Once ignited by lightning or human activity, it can burrow deep into the earth, burning its way through underground coal deposits for decades or even centuries. These fires are ghosts in the machine of the landscape, venting smoke through fissures and baking the earth above them into barren, red clay. The city of Centralia, Pennsylvania, offers a quiet testament to such a fire. A coal seam ignited there in 1962 and has been burning ever since, slowly consuming the fuel beneath the town until the surface became unstable. The streets now steam with volcanic warmth. A modern settlement quietly abandoned to a subterranean, eternal flame. In Azerbaijan, on the slopes of the Yanar Dagh mountain, natural gas, seeping from the earth, has been burning for centuries. The flames dance continuously across the stone surface, a permanent fire that never requires stoking. Ancient travelers saw this as a divine manifestation, a sacred fire that wrote its own timeless story against the hillside. The eternal fires tended by ancient cultures, such as the sacred flame of Vesta in Rome, were not natural, but were kept alive through diligent human care. The commitment to keep a flame burning for generations was a profound act of cultural continuity, a literal and symbolic thread of light connecting the present to the ancestors. The fossil fuels we burn today are themselves the remnants of ancient sunlight, captured by life forms that lived and died hundreds of millions of years ago. When we light a gas stove or a furnace, we are releasing carbon that once floated in primordial seas, making these the oldest flames in their chemical origin. Despite being newly kindled, in a crater in the Turkmenistan desert, the Darvaza gas crater, known as the Door to Hell, has been burning for over 5 decades. A drilling accident in 1971 opened a cavern of natural gas, which was then set alight to burn off the dangerous fumes. The engineers expected it to last a few weeks, but the fire found a deep reservoir of fuel and has become a permanent, roaring pit of flame in the desert. There are peat fires that burn with a slow, smoldering persistence in places like Indonesia and Canada. These fires can travel underground, through the dense, carbon-rich soil for months or years. They are silent, smoky fires, often undetectable until the ground collapses underfoot, revealing the glowing heart within. The oldest continuously burning natural gas fire may be the one at Baba Gurgur in Iraq. This eternal flame is thought to have been burning for over 2,000 years, mentioned in historical records and serving as a landmark for ancient travelers. It was famously used by shepherds to warm their flocks, a practical blessing from a flame that predates empires. On Mount Wingan in New South Wales, Australia, a coal seam fire has been burning for an estimated 6,000 years. The indigenous Wanarua people have known of this burning mountain for generations, incorporating it into their cultural stories. It is the oldest known continuous fire on the planet, a slow geological heartbeat. The concept of an eternal flame at a memorial, such as at the tomb of the unknown soldier, draws from this ancient symbolism. It represents a memory that will not be extinguished by time, a commitment that endures beyond a single lifetime. It is a modern echo of the sacred hearth, a public promise made visible through a single, unwavering flame. The natural nuclear fission reactors found in Oklo, Gabon, are a different kind of ancient fire. 2 billion years ago, concentrations of uranium in the Earth reached a critical state and began a self-sustaining nuclear reaction that burned quietly for hundreds of thousands of years. This was a terrestrial star, a slow atomic fire buried deep in the rock. These ancient fires remind us that our own campfires and candles are fleeting sparks in a much longer story of combustion. They connect us to deep time, to forces that operate on a scale far grander than our own. They are the embers of the planet itself, burning with a patience we can scarcely comprehend, whispering of an age when the world was young and fire first learned to dwell within the stone. The final flicker, fire's cosmic fate. In the deep future of the universe, the era of fire will gently close. The same cosmic processes that allowed the first flames to flicker will, in time, ensure that the last ember cools into darkness. This is not a violent end, but a slow, quiet fading, a final breath in the long story of combustion. The lifespan of a star dictates the availability of elemental fuel. As generations of stars live and die, they forge heavier elements, but they also consume the primordial hydrogen that is the universe's primary energy source. Eventually, star formation will cease, and the galaxies will begin to dim one by one on a future Earth. The slow brightening of the sun will first lead to a great flourishing of plant life. But this very abundance will deplete the planet's carbon dioxide. Without this essential greenhouse gas, the global temperature will begin to drop and the great forests will decline, reducing the primary fuel for natural fires. As the sun evolves into a red giant, its increasing heat will eventually vaporize the Earth's oceans and ignite the very atmosphere. For a brief, terrible moment, our planet will be engulfed in a global firestorm, a final, planetary blaze that will consume every last remnant of biological fuel. After this conflagration, the cinder that was Earth will be left barren and airless. With no atmosphere to provide oxygen and no biological matter to act as fuel, the age of fire on our world will be irrevocably over. The chemistry of combustion will no longer be possible. In the far future of the cosmos, the universe will continue to expand and cool. Galaxies will drift apart, and the interstellar clouds of gas and dust that birth new stars will become increasingly rare and dispersed. The raw materials for new solar systems and thus new hearths will simply be too far apart to gather. The last fires in the universe will likely be the slow, smoldering embers of degenerate stars. Brown dwarfs, failed stars too small to ignite full fusion, may still exhibit faint, localized fusion or chemical burning in their atmospheres for trillions of years. The dimmest and most patient of all flames on some far future rogue planet ejected from its dying solar system. A subterranean fire might persist in absolute darkness. A radioactive decay fire or a slow, tectonic smolder could continue unseen by any eye, its faint warmth the last memory of a star's influence in the infinite cold. The process of proton decay, if it occurs, will mark the true end of all chemical possibility. Over timescales so vast they defy comprehension, the very protons that form the nuclei of atoms may spontaneously disintegrate. When this happens, all matter will slowly evaporate into radiation, and the concept of fuel will become meaningless. In the final state of the universe, known as heat death, all energy will be evenly distributed across an infinite, expanding void. There will be no temperature differences, no gradients to drive any process, be it life, thought, or a simple flame. The universe will achieve a perfect, uniform equilibrium, a state of ultimate rest. The last conscious beings, should any exist in that distant epoch, might gather around an artificial star, a contained fusion reactor, knowing it is one of the final lights in all of creation. Their vigil would be a profound and solemn one, witnessing the closing chapter of a story that began with the first spark in a primordial cloud. The final fire to ever flicker may not be a grand inferno, but something small and quiet. Perhaps it will be the last candle in a vast archive of a long-dead civilization, its wax finally exhausted after an eternity of burning. Its wick will darken, and the universe will become a little colder, a little darker. Yet, in this ultimate quiet, the legacy of fire remains. The photons emitted by every flame that ever was, from the first campfire to the last stellar ember, will continue their journey through the expanding cosmos forever. The light is eternal, even when the fire is gone. This cosmic end is not a tragedy, but a natural completion. Fire was a temporary, beautiful phase in the universe's history, a means for matter to express its stored energy as light and warmth. Its passing is as natural as the cooling of a single ember in a hearth, a gentle return to the stillness from which it first emerged. Weaving the tapestry of light, from the first spark to the final cosmic ember, the story of fire is a single continuous tapestry, woven with threads of chemistry, physics, and profound human connection. Each flame, from the grandest wildfire to the most humble candle, is a unique expression of the same universal principles, a momentary constellation in the long night of time. We have wandered from the quiet birth of a flame in the fire triangle, through the intricate anatomy of a candle, and listened to the silent language of its colored light. We have sat with the humility of its unanswered questions and marveled at its cosmic lineage as a distant cousin to the stars. This journey has been one of deepening perspective, seeing the same phenomenon through different lenses, each revealing a new layer of its gentle mystery. The flame you gaze upon is a process, not an object. It is a river of transformation, a flowing architecture where matter patiently changes its state, releasing energy that was stored in chemical bonds, energy that originally came from the light of a star. It is a temporary bridge between the cosmic and the personal. The same principles that govern a campfire also govern the hearth within you. Your body's metabolism is a slow, controlled flame, a cellular respiration that burns the fuel of your food with the oxygen of your breath. The warmth you feel in your hands is the same energy, the same fundamental process of oxidation happening on a different scale and at a different speed. Humanity's journey with fire is the story of a relationship deepening over millennia. We moved from fearing its wild, untamable power to inviting it into our homes as a protected guest. We learned its rhythms in the forge, using its patient heat to transform stone into glass and metal into tools, slowly weaving the very fabric of civilization with its assistance. The fuel for a fire can be as solid as an oak log, as ancient as a fossil, or as ethereal as human will. It is all ultimately captured sunlight, a battery of energy waiting for its moment of release. And the oxygen that enables it all is the silent, ever-present partner, the breath of the atmosphere that makes the conversation of combustion possible. We have seen fires that burn for millennia, eternal witnesses to deep time, and contemplated the last flame that will ever flicker in a cooling cosmos. This vast timeline frames our own brief moments by the hearth, giving them a poignant and beautiful significance. We are temporary keepers of a timeless phenomenon. The flicker of a flame is a visual lullaby, its chaotic yet gentle dance a signal of safety to our deepest minds. It does not demand focus, but allows it to soften and drift. In its light, we find permission to let go of the day's complexities, to simply be and to rest. So, as you watch the gentle dance of light and shadow, remember that you are connected to all of it. The carbon in the soot was forged in a star. The heat on your skin is a form of ancient sunlight. The calm in your mind is a gift from a force that has guided human evolution since its dawn. You are not separate from the fire. You are a part of its ongoing, beautiful story. Every flame is a brief, bright word in a silent, ongoing story told by the universe itself. It is a story of transformation, of energy's endless journey, and of the fleeting, beautiful forms it takes. Your quiet attention to it is a part of that story, a moment of shared existence between the observer and the observed. In this final synthesis, the boundaries blur. The fire on the hearth is the fire in the stars, is the fire in your cells. It is all one magnificent interconnected process. There is no separation, only a single flowing tapestry of light, of which you, in this peaceful moment, are a part. Let this unified vision bring a deep and final calm. There is nothing more to solve, nothing more to understand, only to experience, to feel the connection, and to rest within the gentle weaving tapestry of light. And now, the gentle dance of the flame begins to soften behind your closing eyes. The flickering light recedes, leaving behind a warm, comforting afterglow that settles deep within your mind. We have drifted together through so many quiet wonders, from the first spark of chemical conversation to the cosmic fate of the last ember in the universe. We have explored the silent language of light, the hearth within your own cells, and the ancient, patient fires that have burned for millennia. You have wandered through the very heart of transformation itself. Tonight, as you rest, fires continue their quiet work elsewhere in the world. A candle burns in a distant window, a hearth glows in a mountain cabin, and the slow, smouldering heart of the earth itself ticks on. And you are floating within it all, a quiet center of warmth and awareness in the vast, gentle dark. You are part of this great, slow story. The same atoms that dance in the flame are in the air you breathe. The same warmth you feel on your skin is a relative of the sunlight that fuels all life. You are not just an observer of this tapestry of light. You are woven into its very fabric, a vital thread in the grand, quiet narrative of the cosmos. There is nothing more to do now. No thoughts to hold, no knowledge to grasp. Let it all go as easily as smoke rising into a still night sky. Your journey is complete. If your mind is still drifting among these gentle embers of thought, let them fade. Simply allow yourself to be here in this peace. If you are still awake, you are welcome to stay, but I hope you will soon drift into a deep and restorative sleep. Thank you for sharing this quiet space. I hope you sleep well and dream of soft, glowing horizons. Good night.